for our one pager is we're going to fold into thirds. So my book actually has the front page says Math 1, semester exam, one page. Okay. So you guys, are you with me? Okay. So let's just talk about Unit 1. Now, it is my advice that you do this in pencil, and it says that on the back. Like, hey, some suggestions. 1, do it in pencil and then go through afterwards with a highlighter or a marker or something to make it just better for you. Okay. So I'm going to just try to do all of this in one color so you guys kind of model that, and then you go back through. Now we're going to try to fit everything that we need for Unit 1 right here, but I'm going to write small so that way if I want to put extra stuff in there, like examples on solving a multi-step equation, I can do that, okay? All right, so our first page is going to be our Unit 1 page. So Unit 1. And I'm going to try to write small. This is Unit 1, equations. So the first item that's on your test is to write equations or expressions from words or word problems. So I need to look at 0.2 from my journal and 1.1. I need to know how to translate words into math. So I am just going to make a small little table right here. This is how I would do my one pager. And I'm going to write down words that mean plus, words that mean minus, words that mean multiply, and words that mean divide. I'm also going to write down words that mean equal. Do we need the inequality symbols? Do you guys need those words? You would like them? Okay. So less than or equal to, greater than, or equal to. So let's think of some words that mean addition. Sum. That's probably the biggest addition word. What are some other words that mean? Does anybody want a ruler? I see some of you guys are. Yeah, if you want a ruler, because it's going to freak you out if your lines aren't straight. Yes. Okay. Who else wants a ruler? You guys are so cute. This is not supposed to be like something super tedious that's going to make you crazy. It's just supposed to be notes, okay? So don't make yourself crazy. Anybody else want a ruler? Yeah. You can't read your own handwriting? Okay. It's supposed to kind of be fun, kind of like doodle notes. All right, don't get stressed about it. So, sum. What's another word that means addition? Add. Yep. Add. What if I said 5 more than 2? That means 5 plus 2. Right? Remember that word, more than, which is different than is more than. That's the greater than symbol. When it's got the word is with it, that's the greater than symbol. This is just an expression. Okay? I think those are some good addition words. Don't kill it. Don't put so much on there that you can't read it. Just need a couple. What do you think about subtraction? Difference, yeah. That is probably the most common Subtraction word. Difference.
Less than.
Less than. And it's written just like that. Not is less than, but less than. And I'm going to give you an example. 2 less than 5. Less than is one of those flip words, right? It means 5 minus 2. Less than is a turnaround word, right? I think those are good. Okay. What symbol means that we need to multiply? Or what word means that we need to multiply? Times. That's a good one. What else? Product. Yeah. That is probably the most important one. Times and product. I think that's good. Oh, what were you going to say? Multiple. It's saying plug in your computer. I'm doing that. Okay. What about words that mean divide? What are some division words? I think the most popular one is quotient. I think that's the most popular, quotient. I mean, we know divided by, but quotient is the one that you're like, what is that really asking me to do? What is the most common equal word?
Equal to.
Equal to. Okay. Let me tell you the most common equal word. I'm going to write it big. Is. In a math statement, the sum of 2 and 5 is 7. Okay. We're not going to say is equal to. We're just going to say is. So look for that. Is means equal. Don't let that throw you off. Okay. The less than symbol is less than, or is fewer than. The cool thing about putting the inequalities on here, I'm glad that you guys agreed to do that, is because now you know when you see that symbol, because we are still trying to figure out sometimes when we look at that, when I'm graphing an inequality, especially a linear inequality, you have a hard time looking at it and seeing, is that a less than? Do I shade below? Is that a greater than? Do I shade above? And now you have them written down for you. Okay? So that's a good idea. What about the next one? Less than or equal to? Well, this one is weird. So I'm going to write less than or, let me try that again. Less than, trying to fit it in here, or equal to, I'm using a symbol just so I can get all the words in there. But I would say like the weird ones are when I say at most or no more than. Those are the two odd phrases that mean less than or equal to. You can have at most 3 pieces of candy. That means no more than, right? Less than or equal to. Okay. And then our next one, well, that's just the greater than symbol. So is greater than. Or you might see is more than. Okay. Is greater than or is more than? So what do you think those weird phrases are going to be for the is greater than or equal to? Greater than or equal to. So that's a great one. At least. Think along the lines. So at most and at least kind of go together. Think along the lines of no more than. What's kind of the opposite of no more than? No less than. Yeah, good job. I would say that that's pretty solid and that's pretty important. That takes care of your writing equations / expressions for word problems. Those are like the key. And again, I'll post this, but I'll scan my filled out one later. Writing equivalent expressions and simplifying expressions, that's just combining like terms. Do we need an example of that? I'm just going to write combine like terms. And I'm just going to put a little note. Like terms have the same variable raised to the same power. Okay. Same variable raised to the same power. That's what we need to know. It's the same variable raised to the same power. So just because they all have x's on them, just because all of the terms have x's doesn't mean you can group them all together. They not only have to have the same variable like x, but those x's all have to have the same exponent on them. Because if they don't, they're not like terms. Okay? I think that's all we need for simplifying expressions. Would you guys agree? Okay. Does everyone feel good with distributing? Do I need to draw an example of distribute, or you feel like you can do that in your sleep? Are you kidding me? I'm going to do it for you. I'm going to make it be a -4 times x minus 3. When I distribute, guys and gals, I'm 52 years old and I still do this. I still use arrows just like that. So I don't forget, because otherwise I always multiply the first term. Always. But sometimes I get a little lazy and I don't multiply that -4 by the -3. I forget. Do you know what I mean? Like, so I draw those arrows to remind myself. So we know that this means -4x plus 12. Simplifying multi-step equations and multi-step inequalities. I don't think that you need anything in there except there's a special rule about inequalities. What is the inequality rule? We solve equations and inequalities exactly the same, except for one thing. Maybe look at your 1.7. We solve inequalities and equations the exact same way, except for one thing. Something really special. It's hurting my heart that you guys aren't remembering that. Making me a little anxious. What do you got, Owen?
So I see that it says when you eliminate the coefficient last step, you will need to flip the inequality if you multiply or divide by negative.
I love that. So when you multiply, and I'm going to abbreviate that, mult / div, because these are notes. When you multiply or divide by a negative. And I'm going to go back with my highlighter and kind of highlight that in when I look at my notes again. When you multiply or divide by a negative, you must flip the inequality symbol. That's really important. That's the only thing that's different. Okay. Do you guys remember that rule? Yes, now you feel better about it? You know what we're talking about? Okay. What about sums of consecutive integers? What the heck is a consecutive integer? When you see consecutive integers, what does that mean? That means like 3, 4, and 5. -2, -1, -3, right? Numbers that come in a row. That's what that means. So when I have the sum of consecutive integers, like if we're writing an equation, we call them x plus 1, and x plus 2. Right? We didn't put any consecutive even or consecutive odd on your test. I got voted down on that one. So you're welcome. The cool thing about that is your test is mostly fill in the blank or multiple choice, not a whole lot of equation writing. And a consecutive integer question, I'll just tell you right now, the sum of 3 consecutive integers, you can probably use a calculator and figure that out. I tell you the sum of 3 consecutive integers is 67, right? Or, I don't know, not 67. How about 57? The sum of 3 consecutive integers is 57. The first thing I'm going to do is take 57 and divide it by 3, right? And that's going to give me 19. And I'm going to go one above it and one below it. 18, 19, 20. Okay? So you're not writing an equation, you're just filling it out. So they're just consecutive numbers in a row. You guys will be able to figure it out with a calculator. Okay? All right. Last one is cost, revenue, and break even. So cost, it's money you spend to start. Revenue, it's money you make from sales, from selling whatever you're creating, right? Profit is your revenue minus your cost. You have examples in your notes. You have examples in your journal. I'm not going to give you an example. So it's going to be like your part of discovery or investigation. But that's all you need for that, okay? The last part of that is break even. What does it mean to break even? Say that again. Yeah, you don't lose any, you don't make any. That means that your cost is equal to your revenue. Ken, was that you that said that? You got a good business mind. That's awesome. Your cost is equal to your revenue. Do you guys have like lawn mowing businesses or anything like that? Any kind of side jobs that you do? Yeah. So that's really important for you. You guys have a tree business, don't you, Hayden? Do you know? So, Ken, do you have a mowing job? Yeah. So, when you think about gas prices increasing, you're going to have to raise how much you charge someone to mow their lawn, or you're not making any money, right? You get less of a profit. Okay. Do we feel good about those? Okay. I'll leave that there for one more minute. I see some of you are still writing. I'm going to go to my Unit 2 functions. And I'm going to look at my little list of what it needs to take or what it needs to have on it. And we're going to talk about what we should put in our Unit 2 functions. Is everybody good with this? Okay. Is this helpful for you? Yes or no? Because if I'm wasting your time, I want to know. Yes, it is? Okay. So Unit 2 functions. Now remember, you should have some more space on that paper. You can add whatever else you think you need, but these are the things that are specifically on your test, okay? Go back through with a highlighter afterwards. So writing a function from a table. Writing a function from a table. So I'm just going to make a table of values. This is my x, and this is my f of x. It could also be y, z, it could be any variable, really, right? I'm going to use the numbers -2, 0, 2, and 4. I'm doing that on purpose. I'm not going in order on purpose to make you guys think about what's happening. And then I'm going to use 5, 10, 15, and 20. So when you write a function from a table, what is the first thing that you need to look for? Slope, which, oh my gosh, is the same thing as average rate of change. Because that's one of the things down there on the bottom. Slope and average rate of change, those are all the same. Okay? Don't get caught up on the verbiage. It means the same thing. So slope, that is my change in the y variable over the change in the x variable. So let's look at what's happening on the y side. +5, +5, +5. So my change in y is 5. What is my change on the x side? What am I doing over here? +2. Okay? So that means that my slope is 5/2. I also need to find my what? Rate of change and slope are the same thing. I need my y-intercept, right? The y-intercept happens when x equals 0. Your y-intercept happens when x equals 0. And lastly, you write the equation y equals m times x plus b, or f of x equals m times x plus b. I did get your message, and we are just videoing. You're so amazing. Nope, nope. Remember that your slope is your m, and your y-intercept is your b. Okay? How do we feel about that? Okay, that's it, right? And we've practiced that so many times. I feel very confident that you guys can write an equation with the slope, finding the slope, and then working backwards to find the y-intercept, okay? So our next stipulation says, hey, what makes a function? Function rules. That's something that you need to know. So let's just talk about a function. What is a function? So there are two things that really make a function. The first one is no repeats in the domain. And I'm going to put x in parentheses. No repeats in the domain. And then the next one is it passes the vertical line test. I'm going to give you an example for these just to make sure you understand, okay? So no repeats in the domain could look two ways, right? It could look two ways. It could be a mapping. This is called a mapping, where you have arrows mapping one number to another number. I want you to draw it just like I did that one. So when you look at that mapping, is this a function? Why? It has two arrows coming from the same number. Two arrows from the same number. Yeah, the rule is exactly one input, one output. It is.
So, am I doing something wrong? Do you see how it says problem is available only to school subscribers?
Yeah, I don't think you are, but I'm seriously going to send them. Are you using it for your next class?
Yeah, but I'm logged in, so what is the?
I don't have any idea. I don't know, but I promise you I'll do it like in 3 minutes and send it to the printer. I'm so sorry. No, I don't think it's you. I just think it's, if you are, it's not me. It's me. It's me. Another way that you might see it is like this. You might be given a set of ordered pairs. -2, 1, 3, 4, -2, 5. Is this a function? Why?
It's not, because there's two negative twos.
Repeated. X. So that makes it not a function as well. Not a function. Is that helpful? Okay. And then for the last one that passes the vertical line test, I'm just going to do a little graph. Just going to draw a little sketch that looks like this. Would this graph pass the vertical line test? Why? Yeah, when I draw a vertical line, my vertical line touches my graph more than once. Yeah, good job. So this is another example of not a function. Not a function. Okay, I'm going to go to evaluating functions. I don't know why we struggle with this so much. I wish I could unlock your function brain and figure it out. So I'm going to give you a couple of examples. I'm going to tell you that g of x is the function x squared plus x minus 4. And I'm going to tell you that f of x equals 3x minus 7. If I asked you to find if I said f of -2 equals, and then I wrote g of 2 equals, what does that mean? I lost connection. Oh, there you go. We caught back up. I was ahead of you guys, sorry. What does that mean? We have to know. I'm not going to tell you. Look at your warm up. We just did this. What does that mean? So what would I do with this? Tell me exactly what I would do here.
I'll put -2 for x.
-2 for x in what? Good job. In the f function. That's what I wanted to hear. Yes, ma'am, you're exactly right. So 3 times -2 minus 7. So f of -2 equals -6 minus 7 is -13. G of 2, what would I do for that one? What would I do for this? Someone other than Ariana. Yeah? In which one? So 3 times 2 minus 7? What is the name of this function? This is the g function, so you're going to use this equation. The reason I'm showing you this is because you might have a question that has 3 different functions, f of x, g of x, and h of x. And it just tells you to find h of 2, g of 7. Does that make sense? You have to know what function you're plugging that number back into. Okay? So this says, hey, I want you to evaluate the g function when x is 2. So let's see, I have 2 in place of my x squared plus 2 minus 4. Well, we know 2 squared is 4 plus 2 minus 4. What does that equal? Hello, wakey, wakey. It equals 2. Okay, average rate of change is the same thing as slope. I'm not going to go through that with you guys. I'm going to do the linear function sequence part, and then I'm going to let you on your own, okay? I'm just going to go to Unit 3, and I'm going to talk about linear functions, sequences. So the Unit 3. We wrote down the explicit and the recursive form the other day. It's on your warm-up or on your sequence packet. Someone needs to get that. Recursive and explicit. Actually, I'm going to stop right here. This is on your sequence packet that I just did with you. We wrote down the recursive formula and the explicit form. We wrote down when you use the recursive and when you use the explicit. Do you guys remember that? It's on your sequences. When do you use the recursive formula? When you want to find the next term, yeah. When do you use the explicit formula? When you want to find the nth term. What is the equation to the recursive formula? All right, I'm going to pause. I'm going to stop our video.